You are looking live at a Falcon 9 rocket on the launch pad at the Cape Canaveral Air Force Station in Florida. At 1:16 this afternoon, the aerospace company SpaceX will launch a Dragon cargo spacecraft on a NASA mission to resupply the International Space Station. Good afternoon and welcome everyone to NASA's Kennedy Space Center for our live team coverage of the launch of cargo resupply mission number 16 for SpaceX. I'm your host, Daryl Nail. As you can see behind me, the iconic NASA countdown clock, which is counting us down to launch. It currently reads about 30 minutes until launch. It is a beautiful day here on the Space Coast as we count down to this mission to fly much needed astronaut supplies and research experiments up to the International Space Station. And we have a team of correspondents across the country helping us to cover all the angles of this launch. We will head across the river here to the Mission Directors Center to get updates on the weather and the countdown. And we'll head way out west to SpaceX headquarters in Hawthorne, California, and check in at Mission Control Houston in Texas. We also have a correspondent standing by with a live interview of Kennedy Space Center Director Bob Cabana. But first, here are some quick facts you need to know about today's launch. SpaceX transported the Falcon 9 rocket out to the launch pad and lifted it to vertical launch position for the 16th cargo resupply mission to the International Space Station. The launch window today is instantaneous, which means SpaceX must launch at the exact second for the planned liftoff or try again another day. The Dragon spacecraft will deliver about 6,000 pounds of astronaut supplies and payloads for science research to the orbiting laboratory. The plan is to keep the Dragon spacecraft docked to the station for about 5 weeks before bringing it back to Earth. When it does, the capsule will splash down in the Pacific Ocean off the coast of California. And today's launch was originally scheduled for yesterday, but it was delayed 24 hours in order to replace contaminated food in one of the rodent experiments testing the effects of aging in space. The new food was flown in overnight and was loaded into the Dragon spacecraft and is now ready to go. The move did come with a big benefit. Weather conditions for launch improved dramatically. Let's bring in NASA's Joshua Santora, who is in the Mission Directors Center just a few miles away from the launch pad. It was a little breezy earlier today, Joshua. It's settled down a little bit. How is the weather looking for launch, though?
Yeah, good afternoon, Daryl. You're 100% right. We did have a little bit stronger winds earlier, but they have calmed down. And right now, everything is go for launch. We heard from Clay Flynn, the launch weather officer for the U.S. Air Force 45th Space Wing Weather Squadron, reporting that we are 90% go for launch. That means there's a 10% chance that we're going to violate our weather constraints for launch. And it really is just those ground level winds that are a potential problem. Again, we're still go for launch. Upper level winds look good, and everything else, obviously there you can see the sky is very, very clear today. It is a beautiful day outside, a great day for launch. We're also, we heard earlier that our COLAs, or our collision on launch assessment, is clean, which means we have no issues there. The range keeping an eye on things for us for public safety. And at 38 minutes to go, we had the poll from the SpaceX launch director, Mike Taylor, who gave us a go for fueling, which began at 35 minutes and counting. So we are into the first stage fueling. So Daryl, everything looking good? Back to you.
Some beautiful shots on the pad there, Joshua. Thank you for the update, and we'll check back with you a little later to see how the rocket's doing. Meanwhile, today is a national day of mourning. Funeral services are being held in Washington, D.C. for President George Herbert Walker Bush. He passed away last week at the age of 94. Today, NASA is joining the rest of the country in mourning the passing of an American president. NASA Administrator Jim Bridenstine issued a statement saying, in part, President Bush's space exploration initiative helped us to think big and long-term about space, and it can still be felt in our ongoing efforts to send humans farther into the solar system to live and work for extended periods of time. And you can see we have the flag at half-mast today. Right now, we are at T-minus 26 minutes and counting. Let's head way out west to SpaceX headquarters in Hawthorne, California, where the Falcon 9 rocket was designed and built. Alex Siegel is joining us live from SpaceX's Mission Control Center. Alex, what kind of work did you guys do to prepare this rocket and Dragon spacecraft for launch?
Well, thanks, Daryl. Our final cargo load happened in Dragon about 24 hours ago, and the vehicle was raised to its vertical position just 8 hours ago, so fairly recently. The team is currently tracking no issues, and we are on track for an on-time launch today at 1:16 p.m. Eastern Time. Propellant loading began on the vehicle at T-minus 35 minutes. As you may recall, to make fire you need 3 key elements. That's fuel, oxygen, and an ignition source. Falcon 9's fuel is RP1, and our oxidizer is densified liquid oxygen, or LOX for short. We should be all full by about T-minus 5 minutes for RP1 and around T-minus 3 minutes for LOX. Our ignition source is a chemical mixture called TTAB, which stands for triethyl aluminum and triethyl borane. This mixture burns when it contacts oxygen in the air, so watch for that cool green flash near the engines right at launch. The final helium loading step will begin shortly. Helium keeps the tank pressurized when we're emptying out its propellant during ascent. Dragon is also getting ready in parallel. It began its auto sequence at T-minus 35 minutes. That's when it coordinates timing with Falcon 9 and makes sure its systems are all healthy. Next big step for Dragon is to move to internal battery power at T-minus 7 minutes. Our Dragon spacecraft has been flying for 6 years now, and it's currently the only vehicle flying that can deliver significant cargo both to and from the International Space Station. It has been quite a journey to get to this point, and it has been a wild ride to be a part of it. In 2010, SpaceX became the first private company to send a spacecraft to orbit and return it to Earth. 2 years later, in 2012, Dragon became the first privately developed spacecraft to visit the space station. Since then, SpaceX has made a total of 14 trips to the station, and we're under contract with NASA for a total of 26 cargo resupply missions. As of now, we're only flying cargo missions, but very soon, we'll be flying humans to space as part of NASA's Commercial Crew Program, with our first uncrewed demonstration mission, called Demo 1, targeted for January of next year. Incredibly exciting. Back to you, Daryl.
Certainly looking forward to that, Alex. SpaceX's Alex Siegel in Hawthorne, California. Thank you. Now, one of the many science investigations going up today is research in how to grow the best superfoods for astronauts while they are in space. NASA's veggie program is sending up Mizuna, a highly nutritious mustard green. Astronauts will grow a half dozen of these plants on special pillows while changing the quality of the light.
The different veggies are going to be set to different red to blue light ratios so we can understand the impact of light quality, spectral quality, on how well the plants grow, how nutritious they are, and how they taste for the astronauts.
The experiment will also study how growing plants in space affects an astronaut's mood. And a surprising update to a veggie experiment from 2 years ago. You may remember astronaut Scott Kelly grew zinnia flowers in space, even made a little bouquet out of them. Well, NASA tried to germinate seeds from those space flowers for 2 years back on Earth without any success until recently. A NASA intern by the name of Lane Diasa was asked to give the seeds another try, and somehow she got the space seeds to grow. Well, word got out, and now these Earth-grown space flowers have celebrity-like status.
They had heard of the flowers and they wanted pictures of them.
Now, Diasa says she didn't do anything special, just used plain tap water. NASA is now trying to figure out what made the 2-year-old space seeds suddenly grow. From the forest to the beach, a restoration of the dunes is underway at the Cape to protect the many launch pads here, as well as other launch infrastructure. Beach quality sand is being trucked in from inland locations and piled up along the dunes to help stabilize it from ongoing erosion. And one of the launch pads protected by the dunes and the restored dunes is Launch Complex 40, where liftoff of today's rocket is timed right down to the very second. The reason for this, SpaceX needs to get their cargo spacecraft lined up to rendezvous with the International Space Station. And for more on this, let's check in now with NASA's Gary Jordan, who is live in Houston, Texas. Gary.
Thank you, Daryl. And yes, I'm here in Mission Control Houston. You're looking at the International Space Station Flight Control Room. Behind me is the Orbit 2 team, the second of 3 shifts that staffs this room 24 hours a day for International Space Station operations and maintenance. Leading the teams today is Flight Director Royce Renfrew. He's gathering all the information from the flight controllers and overseeing the day-to-day operations right now. Next to him, Laura Beachy. She's the Capcom and takes all of the information from the flight control room and sends it to the 6 crew members of Expedition 57 aboard. Now on board since June is NASA's Serena Auñón-Chancellor, Alexander Gerst of the European Space Agency. He's the commander of Expedition 57 right now, and Sergei Prokopyev of Roscosmos. They were joined 2 days ago by 3 new crew members: NASA's Anne McClain, David St. Jacques of the Canadian Space Agency, and Oleg Kononenko of Roscosmos. Right now, all of the USOS crew members, that includes US, Canada, and ESA, are now in the Quest airlock going through some maintenance. But over the next few days, they'll be reviewing some procedures to actually capture the Dragon vehicle scheduled to launch here in just under 20 minutes. They'll be reviewing the procedures to control the station's robotic arm that will capture the Dragon once it arrives slowly but surely over the next few days to the capture point just about 10 meters away from the International Space Station. Communicating with flight controllers over in Hawthorne is the visiting vehicle officer, Nick Fernald. He's overseeing the countdown right now from this room and just going through some of the telemetry, and that position will be staffed over the next few days as Dragon gets closer and closer with the 5,600 pounds of cargo inside. Looking forward to that capture point again Saturday morning. I guess we'll hand it back over to you. Everything's good on our end here in Mission Control Houston. We did a go, no-go poll recently. Station is ready, and we'll be seeing the launch here from the control room in Mission Control Houston. Back to you, Daryl.
Good to know everything looking good on your end, Gary. We appreciate it. He is live at the Mission Control Center in Houston, Texas. And now we want to welcome those of you just joining our coverage of today's launch of a SpaceX Falcon 9 rocket with the Dragon cargo spacecraft, which is headed to the International Space Station. Launch today is an instantaneous window at 1:16 and 16 seconds this afternoon. If SpaceX can't hit that window, they do have a backup set for Friday at 12:27 in the afternoon. Now, there are thousands of people who visit Florida and the Space Coast to see a launch like this, and we have some special guests here across the Kennedy Space Center who are watching it. And right now we want to head over to NASA's Tori McClendon, who is with Center Director Bob Cabana for more on this. Tori.
Thanks, Daryl. Bob, the first assembly mission to the International Space Station happened 20 years ago yesterday on December 4th, and I hear that you were part of that mission. Tell us what that was like.
Oh, it was awesome, Tori, to command that mission and be able to put the first 2 pieces of the space station together. And next Monday, the 10th of December, that'll be the 20th anniversary of the first ingress into the International Space Station. And it was a fantastic event. Great mission from start to finish. And, laying the cornerstone for the space station. What an awesome way to start the assembly.
I agree. So with all the time that you spend on the space station, what would you say that you enjoyed the most?
Well, I didn't get to spend that much time on it. We were only inside for a couple of days. But I think what I enjoyed the most was we stayed up really late one night. And it was just Sergei Krikalev, me, and Jim Newman. And we were taking out launch restraint bolts and doing get-ahead work. And we were just talking about the future of what it meant to have this International Space Station. What was it going to bring? What's the future of space? And to lay the groundwork for it, it was just awesome.
So can you give us a little bit of a look ahead at what's in store for the teams here at Kennedy Space Center in 2019?
We have an awesome year in front of us. I mean, one of the major things we're going to do is start flying crews to the International Space Station on a U.S. rocket from right here on U.S. soil. And hopefully we'll get an uncrewed flight with SpaceX in January and then crew in April, and Boeing on an Atlas V, ULA Atlas V off of Pad 41 with a test flight probably March timeframe, and then crew in August, hopefully if everything works out. But we got a lot to do in order to make that happen, but I'm really looking forward to it. And then we are preparing to go forward to the moon and onto Mars with SLS and Orion and all the infrastructure here at KSC necessary to...
I agree. I think we're all very excited to sit back and watch it all happen and be part of it as well.
Amen.
Well, Daryl, Bob, thank you for joining us.
Absolutely. And what a great day for a launch here at America's premier multi-user spaceport.
Beautiful. It's so beautiful out here. Daryl, with that, we'll go back to you.
That's right. The conditions are great, and a great look back and forward by Center Director Bob Cabana. Tori, thank you for bringing that to us. We are now just 15 minutes away from launch. Let's head back now over to the Mission Director Center, where Joshua Santora is monitoring communications between the launch managers at this time. Joshua, any big updates about the countdown?
So things are really progressing according to plan, which is great. Just a minute ago, we had the second stage begin its fueling. So obviously, the Falcon 9 is a two-stage rocket. The first stage we mentioned started fueling a while ago. That second stage is not as big, so it doesn't require as much fuel. So it's the beginning of its fueling process starts later. This is a approximately 230-foot tall rocket, about 12 feet in diameter, and the first stage has 9 Merlin 1D engines. Those will ignite at liftoff, producing over 1.7 million pounds of thrust. It's great to have 9 for the sake of redundancy. They can actually have up to 2 of those shut down and still be successful in their mission, which is phenomenal. The second stage has a single Merlin vacuum engine, and it's referred to that way because it ignites in the vacuum of space. So once we're done with that first stage, after its job is done, it will separate and then the second stage starts, and that vacuum engine will produce about 210,000 pounds of thrust, which is great. Again, all on the order of getting to the space station. Much like a quarterback in American football throwing to a receiver, you want to aim where the receiver is going to be, and so that's very much what we're doing. The Falcon and Dragon are taking off, headed to intercept the orbit of space station and rendezvous. Hopefully here Saturday morning is the plan. So, Daryl, again, things look great over here. We heard from the launch director things are good. From the weather office, things are good. So we're proceeding according to plan and scheduled for that 1:16 and 16 seconds liftoff.
Great way to look at it, Joshua, a timing route in the NFL. Throw the ball to where the receiver's going to be. That's exactly it. Thank you for that report. And we'll check back with you in a little bit. The activity around the Falcon 9 rocket now picking up as we get closer to launch. Let's head back out to SpaceX headquarters in California and Alex Siegel, who is here to explain that part of the story. Alex.
Well, Daryl, we just passed T-minus 13 minutes, and that means Falcon 9 is stepping into the final phases of terminal countdown. In these last few minutes, the rocket is performing final checkouts to make sure all primary systems will work in flight. Those checkouts include the communication systems and the avionics systems, which are all looking nominal, which is great news. Engine chill began a few minutes ago at T-minus 7 minutes. That gets the engines cold enough to safely move propellant without causing it to accidentally boil. Next are the thrust vector control checkouts at T-minus 3 minutes, where we wiggle the engines to make sure they'll be able to properly steer Falcon 9 during ascent. At T-minus 1 minute, Falcon 9 will enter startup mode where the rocket is in full control for the remainder of the countdown. Dragon is also performing its own final checkouts to make sure all of its primary systems will work in flight over the 2 days it takes to get to the International Space Station. Just before liftoff, watch to see the strong back retract just slightly to give Falcon 9 more clearance during launch, just a few moments from now. Let's kick it back to you, Daryl.
All right, Alex Siegel live in Hawthorne, California. Thank you very much. And like any long road trip, you got to have enough fuel if you want to get to where you're going. You also need to have places to refuel. Well, the same is true for deep space exploration. Earlier, I spoke to NASA's Jill McGuire, a project manager with Goddard Space Flight Center, who is sending up technology to test on the ISS how they can refuel spacecraft in space.
Jill, you're not going to be able to literally put a gas handle into the side of a spacecraft, so it has to be done with robots and equipment, right? Is that what you've got here?
Exactly, yes. These tools are going to be used to simulate exactly how you would go refuel a car. Well, so there are spacecraft right now that don't have that ability. So we're going to take tools like this, such as the cryogen servicing tool, where you can see that it's got rollers on it that are going to be used to feed a hose from our our source store that's on board filled with liquid methane into an empty receiver. door. Again, simulating an empty gas tank. So we'll feed the hose through once we've used this tool, which is called the Viper, or Visual Inspection Posable Invertebrate Robot, bigger acronym. There is a high definition camera at the end of this that again will be used to show whether or not we've got the hose inserted into the receiver door. The tool closest to you there is called the multifunction tool, and it is designed to be able to pick up different types of adapters. Again, just instead of flying, if you needed 8 tools to do a job to fix your spacecraft, you don't want to have to fly 8 big tools this size. So the idea is you fly 1 tool and 8 adapters.
Numerous adapters.
Yes, numerous adapters. Similar to how you do a socket wrench in your garage if you were trying to fix a car.
You got a robot here to wash the windshield as well?
No, unfortunately we don't do windows. No, sorry.
Just fuel. Just going to help you get there.
Yes.
Jill McGuire, thank you very much. We appreciate it.
You're welcome. Thank you.
And if proven, that same technology could be used to refuel old satellites in space that have run out of fuel, as well as next generation satellites that have refueling technology built into them. And now we want to welcome in our viewers from social media who are watching online on YouTube, Facebook, and other social media sites. Thank you all for joining us. We are now just almost 9 minutes from launch, and the excitement is building as the moment of blastoff gets closer. Now, here are some quick facts you need to know about today's launch. SpaceX transported the Falcon 9 rocket out to the launch pad and lifted it to vertical launch position for the 16th cargo resupply mission to the International Space Station. The launch window today is instantaneous, which means SpaceX must launch at the exact second for the planned liftoff or try again another day. The Dragon spacecraft will deliver about 6,000 pounds of astronaut supplies and payloads for science research to the orbiting laboratory. The plan is to keep the Dragon spacecraft docked to the station for about 5 weeks before bringing it back to Earth. When it does, the capsule will splash down in the Pacific Ocean off the coast of California. And now, what do the Guardians of the Galaxy with Marvel Comics have anything in common to do with NASA's exploration of the galaxy? NASA's Greg Harlan has this.
Joining us today at the Kennedy Space Center is Adia Bolowa and Serena Koff, who are going to share with us their winning prizes of the International Space Station's U.S. National Lab and Marvel Entertainment's Guardian of the Galaxy Challenge. Adia, tell me a little bit about your project.
What my project is going to study is the strength of UV light dental glue in space.
Nice. Serena?
My project is looking at the behavior of aeroponic farms in microgravity.
That's pretty interesting. So what got you involved in this experiment?
My mom did. As we were growing up, she always got NASA emails, which inspired all of us to enter the challenges.
Nice. And how about you?
I got this recommendation from my teacher in my engineering class after we'd been involved with NASA Hunch.
That goes to show you that young people are making an impact, helping solve problems, and allowing NASA to get astronauts into deep space.
NASA's Greg Harlan, thank you for that. And now we are just 7 minutes away from launch. I want to send it over to the Mission Directors Center, where Joshua Santora is standing by to take us through the rest of the countdown all the way to launch. Joshua, take it away.
Thanks, Daryl. Yes, we still are on time for our liftoff at 1:16 p.m. Eastern. We are looking to hear for a call that the engines have begun chilling. We heard kind of a rundown of what's going to happen, some of the highlights from Alex. So things that are coming up here as you're viewing the Falcon and Dragon there on the pad. At 7 minutes to go, the Dragon will switch to internal power, and those engines will begin to chill. At 5 minutes to go, the RP-1, or Rocket Propellant 1, should be done fueling the first stage. And then in around the 4-minute timeline, we'll be seeing there's actually a clamp up there at the top of the Falcon just below the Dragon that will release, and the strong back or transporter erector will tilt back a couple degrees, maintaining contact with the umbilicals, the place where the fluid and power and telemetry and other things are provided to the rocket until we get to liftoff. And then at 3 minutes to go, we will have the completion of the liquid oxygen being fueled into the first tank. We'll also have thrust vector control. And then we'll hear calls for the range being go at about 2 minutes. And then at 1 minute, the Falcon will be in startup mode. We'll also hear the command flight computer do a final pre-launch checks, which includes validating the automated flight termination system, which is part of the range. So we talk about the range, and they are ultimately responsible for ensuring public safety. So this includes people being in the physical area as well as people being out over the water where the rocket will launch. And then even in the event that the rocket were to go off course, making sure that it's not going to harm anyone, which is what that flight termination system is all about. But we don't anticipate needing that today. At about 45 seconds to go, we will hear from Mike Taylor, the SpaceX launch director. He'll give a final go for launch. In the last few seconds, we'll see water very intentionally flood the launch pad that you're seeing there on your screen now. And that acts to serve to help cool things, as the heat from launch is a very intense process, as well as suppressing the sound. The sound can be a very violent and disruptive thing, and so the water helps to really kind of quiet those noises. There at the Falcon 9, you're watching as it's venting gaseous oxygen. That's very much anticipated as we actually fill those first and second stages with cryogenic fuel, liquid oxygen, densified liquid oxygen on the order of negative 330 degrees below 0 Fahrenheit. Very, very cold on Earth. In its natural state, that's a gas. And so because they're filling it with liquid oxygen, its tendency is to shift back into a gas. It's why they fuel so close to liftoff, because they want to have as much fuel on board as possible, have it be as cold as possible to allow as much thrust and lifting power as possible.
Cradle arms opening for strong back retract.
There you hear the calls for the strong back to retract, and if we watch closely, it's only going to tip back a couple degrees right now, but you can see if you're watching closely. The Dragon being used today is actually a flight-proven Dragon. This will be its second trip to the International Space Station. Its first was back in March of 2017 as part of the Commercial Resupply Service's 10 mission.
MVAC TVC motions are complete.
This Falcon is a brand new Falcon. SpaceX has said that they will discontinue repainting flight-proven boosters, and so because this one has that nice, beautiful finish on it, we know that this is a brand new one. They will be attempting to land this booster back here at the Cape Canaveral Air Force Station. That's always a secondary objective to delivering the payload successfully into its orbit, wherever it is intended to go.
Retract angle.
There we hear the validation that the strongback is in position. Again, all things go for launch. No technical issues that are being worked or of great issue. The weather looks good. The only real concern was those ground level winds, and those have remained calm. They're slightly calming right now, so still definitely some wind, but not as windy as it was earlier this morning. The Dragon has two main compartments that they're able to store cargo in. There's the pressurized portion, which is what you might traditionally think of as being a capsule. There's about 11 cubic meters of space, 388 cubic feet, which if you have an 8-foot tall room, it's approximately 4.5 feet wide by 10 feet long, just to give you a rough idea. Beneath that pressurized space is an unpressurized storage space that's known as the trunk. It holds about 14 cubic meters, or 494 cubic feet. Again, an 8-foot tall room would be about 10 feet long and 6 feet wide, just to give you a feeling of how big that space is. Again, destined for the International Space Station with a planned berthing Saturday morning. The space station is actually headed this way from Australia. It's flying over the oceans south of Australia as we speak, and headed this way again. The Dragon will plan to intercept that Saturday morning.
Vehicles on internal power.
They're a great call. Vehicle on internal power. Things progressing.
Ground gas close-up starting.
There you see the amount of gaseous oxygen that's venting increasing. This is as the tank gets to that really full point, that they're just making sure that the pressurization and the temperatures are exactly where they need to be.
Ground gas close-up's complete.
Dragon is in startup.
Their Dragon is in startup.
Falcon 9 is in startup.
Falcon 9 is in startup.
Stage 2, press for flight.
Go for launch.
And there's that call, the go for launch call from Launch Director for SpaceX, Mike Taylor.
Stage 1's at startup pressures.
15 seconds.
And Falcon 9 is configured for flight.
9, 8.
8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff as Falcon 9 and Cargo Dragon take flight, bound for the International Space Station with fresh supplies and research, helping to maintain our human presence in space as the station celebrates its 20th anniversary. We expect a small throttle back in the engines as the vehicle enters max Q, or maximum aerodynamic pressure. So we hear that call for max Q, as well as the vehicle now entering supersonic. And the engines are back up to power. That max Q a result of still passing through the atmosphere while the speed is drastically increasing. In about a minute, we're going to see a number of actions happen in very rapid succession. At about 2:23, we're going to see the main engines cut off. At about 2:26, the first stage will separate and fall away to head back here to the Cape Canaveral Air Force Station. At 2:33, the second stage engine will ignite, that Merlin vacuum engine. And at 2:39, the first stage will initiate its boost back burn to return here. There we have main engine cutoff.
MECO. Stage separation confirmed.
And confirm first stage SEP.
Stage 1 boost back startup. Ignition.
There we have a boost back burn. The second stage has ignited. The first stage's main objective is really to get the Dragon spacecraft out of the atmosphere, which it has succeeded in doing. The second stage is now into its mission to deliver the Dragon into its specific orbit. What you're seeing on screen right now is our tracking cameras really working to follow that first stage back as it returns to the Cape Canaveral Air Force Station.
Stage 1 boost back shutdown.
So the boost back burn is complete. There are at least a couple more burns required to get that first stage back down here to the Earth, which we'll keep a close eye on.
Stage 2 is following the nominal trajectory.
Acquisition of signal at Bermuda. We just heard a great call, the second stage there, nominal trajectory. And there you can see on screen, that is a view looking at the engine for the second stage. There's a really beautiful shot looking back where you can see the Earth. The cameras are switching there on opposite sides of the second stage looking at that engine. So just a quick look at the actions that are coming up. We have a few more minutes of the second stage burning, and then it will shut down, and then we'll see spacecraft separation, and then a moment or two later we will see the solar arrays on the Dragon
to follow
deploy.
the nominal trajectory.
Acquisition in New Hampshire.
So as you're seeing, again, everything so far proceeding as expected, what we refer to as nominal, which is everything we would like to see today. But there's still a good bit of work yet to be done, but a lot under our belts. So Daryl, we're going to actually go back to you, and this is going to be me signing off from the Mission Director Center. Thanks for being with me, and we'll see you next time.
Joshua Santora live in the Mission Control Center. Thank you for taking us through the launch. And as the rocket continues to fall now, we are now going to switch gears and monitor the Dragon spacecraft's journey to the International Space Station, but also get this exciting moment for this mission, and that's the return of SpaceX's booster to landing zone 1, which is just about 10 miles to the southeast of where I am located here at the Kennedy Space Center. Let's bring in Alex Siegel of SpaceX back in. He's out in California at the company's headquarters to show us the landing and talk about reflying that Dragon spacecraft. Alex.
Thank you, Daryl. Now, for those of you just joining us, we may have said it before, but this is SpaceX's 20th launch of 2018, and we're launching a flight-proven Dragon spacecraft today, which visited the International Space Station once before for our CRS-10 mission all the way back in March of 2017. You can hear some applause behind us as everything is going great. Both Falcon 9 and Dragon were designed with reflight in mind, so the vehicle hardware is built to support multiple missions with minimal refurbishment in between. And while this Dragon has flown once before, the booster we're flying today is actually brand new. And in just a few moments, we'll be bringing that first stage back to land at Landing Zone 1 at Cape Canaveral so that it can fly again on future missions. Now, in order to make its way back to the landing zone, the first stage executes a series of 3 burns. The first is a boost back burn, which helps to slow the rocket down horizontally. Shortly after this burn is initiated, the grid fins, which you can see right on your screen, located near the top of the first stage, are deployed, and they help guide the rocket during descent. Following the boost back burn, Falcon 9 executes a re-entry burn to slow itself down before hitting the dense part of the atmosphere. Let's watch the action for a moment. So right now we're looking at the second stage, and you're looking at that MVAC-D engine, which is our Merlin vacuum engine, which only operates in space. Now it looks like, as you guys saw a little bit earlier, that the first stage might not be hitting its target, but the second stage is still heading right there. It's sad, if you guys can hear the cheering in the background from my team members. It seems that the first stage has made a water landing, which, again, is not the primary mission here. We still have the Dragon capsule headed to the International Space Station. It is a bummer that we weren't able to capture and re-land the first stage, but again, not our primary mission, so we are still on track to complete this mission. We're going to go back to talking about our primary mission, and again, as I mentioned earlier, you've got the MVAC-D, or Merlin vacuum engine, you see on your screen. The burn, it looks like it has fully cut off. And we'll wait for the nets to confirm that we've had official second engine cutoff. Still waiting for that call out from the nets, so let's give it a few seconds. We just got confirmation on good orbit, so that is great news. Up next, we've got Dragon separation from the top of that second stage, which will give us a glimpse inside Dragon's trunk. As mentioned earlier in the broadcast, Dragon carries cargo both inside the capsule, which is referred to as pressurized cargo, and in its trunk, referred to as unpressurized cargo. And it looks like we have clean separation. You can see inside the trunk right there. What a beautiful shot. With Dragon deployed, the next major milestone will be deployment of the solar arrays as Dragon makes its way to the International Space Station. It's going right back to you, Daryl. Thank you, guys.
All right, Alex Siegel live in Hawthorne, California. Thank you. As he mentioned, there was a bit of an issue with the booster, but Dragon is well on its way to the station right now, still looking for a confirmation of solar array deployment. Let's check now. Back with Gary Jordan out in Houston, Texas at Johnson Space Center. Gary.
Thank you, Daryl. We're seeing the views now of the confirmation of that separation. The next milestone will be when the solar arrays themselves are deployed. Once they're deployed, it'll provide power to the Dragon over this next 2.5 days that it'll be orbiting the Earth to rendezvous with the International Space Station. Once it does, this is scheduled for Saturday morning and is captured by the station's robotic arm. It will share power with the station itself until it's berthed a few hours later. Again, looking at Saturday. The view you're seeing now is a view of the Dragon spacecraft in orbit. You can see some of the tracking. The station itself, at the time of launch, was 261 statute miles over the just south of Australia. Soon we'll be seeing some views. One of the cameras on the Dragon that will actually show us the solar array deployment. In the meantime, we'll stand by for confirmation of that milestone. You can see the Dragon spacecraft being tracked over the North Atlantic Ocean. Space station, in the meantime, tracking 263 statute miles over the South Pacific Ocean, just east off the coast of New Zealand. This is part of the two-orbit rendezvous profile. And it looks like we have a good solar array deployment. Solar arrays are now in motion. Once fully deployed, the solar arrays will begin collecting power. Again, that will provide power to the Dragon spacecraft over the next approximately day and a half, a little bit longer, until the capture to the International Space Station.
Expected loss of signal, Bermuda.
And as the SpaceX flies again over the North Atlantic Ocean, the International Space Station just behind it, 263 statute miles, currently over the South Pacific Ocean of New Zealand. We have solar array deployment, getting good views here from Mission Control Houston. So again, with the successful deployment of those solar arrays, Dragon will be using those to collect power from the sun as it continues to orbit the Earth for the next 2.5 days, looking for rendezvous to the International Space Station early Saturday morning. At the time of launch, the crew of the International Space Station, the Expedition 57 crew, were in the middle of some tasks working on their spacesuits, but also double multitasking and watching a little bit of the launch along the way. They're excited for the more than 5,600 pounds of cargo to be arriving here shortly. Again, included in that is more than 2,300 pounds of science, some of which were described during the launch broadcast today. We have successful deployment of the solar arrays, and with that, we'll toss it back to Daryl over at the Kennedy Space Center. Everything's looking good from here in Mission Control Houston.
Gary Jordan, thank you live from Houston, Texas. We appreciate you taking us through that. And for more updates on the launch and the mission, you can go to nasa.gov/station or nasa.gov/SpaceX. That's going to do it for us. I'm Daryl Nail, and from everyone here at NASA's Kennedy Space Center, we appreciate you joining us for the successful launch and the mission that is going to take the cargo spacecraft to the International Space Station. We're going to leave you now with another look at today's launch and remind you to keep looking up. Have a great day, everyone.
15 seconds.
And Falcon 9 is configured for flight.
9,
8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff as Falcon 9 and Cargo Dragon take flight, bound for the International Space Station with fresh supplies and research, helping to maintain our human presence in space as the station celebrates its 20th anniversary.
Good morning from Charlotte. I'm prior to an update on your weather. Get going.